we're back. This is Math 200. We're looking at Chapter 6. And so what we're going to be doing is factoring. And so 6.1 on the note packet, page 1, we're finding the greatest common factor. So the greatest common factor between two numbers is the largest number that goes into both numbers. And so you wanted to not mix that up with, students often mix that up and they think of numbers they go into. They're thinking of least common multiple. Like between 12 and 8, somebody earlier last semester said 24, and it's not going to be 24. Now you're thinking of numbers they go into. We want numbers that go into them. The biggest number that goes into 12 that also goes into 8. That is the greatest common factor. And so to find that, if it jumps out at you, that's fine. You can just write it down. If there's nothing in between them, like no common factor, then 1 always goes into everything. So 1 is kind of the default. All right, but if you don't see it, you break it down into its primes. So 2 times 2 times 3. Remember those little prime factor trees like this, where it's like 4 times 3, and 3 is prime, and 2 times 2, and the 2's a prime. So 2 times 2 times 3. 8 would be 2 times 2 times 2. And then you only take what they have in common, all right? So to find the greatest common factor, it's only what they have in common. So they have a 2 in common, they have another 2 in common. I can't take the 3 or the 2, that's just throwaway. And then 4. So the GCF of that one, the greatest common factor is 4. The largest thing that goes into 12 that also goes into 8 is 4. Let's look at 7 and 20. Well, 7 doesn't break down. It's already prime at 7. 20 is 2 times 2 times 5. Well, there is nothing in common. So this is one of those that I told you about. They're relatively prime. So then it's 1. 1 is the greatest common. 1 goes into everything. So the biggest number that goes into 7 that also goes into 20 is 1. All right? And we can look at that in different ways where relatively prime. So primes are numbers that are only divisible by themselves in 1, and relative to one another. So this is not a prime number. You know, 2 is prime. Here, let's make a quick list. 2, 3 is prime, 4 is not, because if something else goes into it, like 2 times 2, it's not prime. It can only go in by itself in 1. So 5, not 6, because 2 and 3, 7, not 8, not 9, not 10, 11, and so on. All right, you can make a list of prime numbers. Relatively prime means relative to one another. They don't have anything in common. So they could both be composite numbers, not prime. But if they're relatively prime, that means they don't have anything. All right? X to the third, x to the seventh. We could do it like this. X to the third is x times x times x. X to the seventh is x times x times x times x times x times x times x. 2, 3, 4, 5, 6, 7. All right, and now only what they have in common for the GCF. So the GCF is there's an x, there's an x, there's an x. That's x to the third. So now there is obviously a quicker way to do this. When you have like bases and you're looking for the greatest common factor, you always take the smaller of the 2 exponents because it's got to go into both of them. If I pick the larger, that won't go into x to the third. All right. So smaller of the 2. So here, let's do this one without any of the work, and then I'll do all the work also for your notes. So the greatest common factor between 6 and 4 is 2. 2 is the largest thing that goes into 6, that also goes into 4. And between x5 and x3, I would take the x3. And that would be the GCF. Now, if that didn't make sense to you, here, we can do it the other way. You can go 6x5, 2 times 3 times 1, 2, 3, 4, 5 of them, and 4x3, 2 times 2 times 1, 2, 3 of them, and just take what they have in common, so greatest common factor. So they have a 2, they have an x, and an x. And that's our 2x to the third. All right? Okay. So let's look at the next page. We are factoring out the greatest common factor. So factoring is the mathematical opposite of the distributive property. Okay? It is more difficult. There's more steps to factoring. When you're factoring, you're doing the distributive property in reverse. And just like driving a car, it's a lot easier to drive a car in forward, that's what it's made for, than in reverse, right? I know they have backup cameras and little beepy things, and that helps, but it's still more challenging to drive a car in reverse. In the same, it's more challenging to factor out the greatest common factor than it is just to distribute. So here, look. If I had 3x times 2x minus 7, and I wanted to do the distributive property, these would be the steps. I'd just take 3x times 2x, that's 6x squared. I'd just take 3x times 7, that's just 21x, and then I put the minus back in between them, all right? But if I'm going the other way, then I'm looking at that. Let's say I'm given this and told to factor out the greatest common factor. Well, first I need to find the GCF. So that's 3x. Then the second part, and this is the tougher part, you write out whatever your greatest common factor is, you put it out front, you do an empty set of parentheses, and then to populate that parentheses, you take your greatest common factor that you wrote out front, and you write it under each term. And then it becomes like 2 little problems. In this case, just 2. You reduce that term by term. So 6x squared over 3x. The 3 goes into 6 twice. One of the x's, remember, that's x1, that's x2. So one of those cancels. So 2x. The minus comes down. And then the x's go away. But 21 divided by 3 is 7. And that's factoring out the greatest common factor. So let's go back and look at this again. Easy peasy. You're multiplying. Doing the distributive property, there's really no work to it. It's just you have to know how to multiply, obviously. You have to remember to add up the exponents. But compared to this process is a lot easier. Now, they are mathematically opposite because, look, this one transformed it into 6x squared minus 21x, and this one transformed it back into 3x times quantity 2x minus 7. So they are mathematically opposite, but I wouldn't say it's... I don't mind saying it's the opposite, but I don't like to say it's just the distributive property in reverse, because then that just makes it sound like it's the same difficulty, and it's not. It's not. It's more difficult to divide and cancel and reduce and stuff than it is to just multiply. All right? So let's do some problems. It's not to say you can't do these. I'm just saying just know that they're a little more work. So in this one, the GCF would be 12, 6, and 9 would be 3. And then x squared, or x to the third, x. So that would be the GCF. All right, and then I do a big old empty set of parentheses. And whatever I wrote there, I put underneath each term. So I divide this by 3x, this by 3x, this by 3x. And then we get 2x squared minus 3x plus 4. And so look, those x's cancel. 3 goes into 12 4 times. That kills one of the x's. 3 times. That kills one of the x's, so it's x squared and 2. So 2x squared, 3x, and 4. If you weren't sure how we got that GCF, I'll do one more with the GCF. But you'll eventually just get the hang of finding the GCF there. So GCF, to find the GCF for it, like the long way, 6x to the third would be 2 times 3 times 1, 2, 3 x's. 9x squared would be 3 times x times x. And 12x would be 2 times 3 x. And I remember a question from most of the semesters I taught that. Students are like, hey, why didn't you take the negative? We don't care about the negative. That's just following it down, you know, the minus. So when you're finding the GCF, just take the number without the sign, all right? And greatest common factor. So they all don't have a 2. So see, this one ruined it for 2. They do all have a 3. And they do all have an x. But even though those two have another x and these two have a 2, you can't take them. It's got to be in all 3 or nothing. It doesn't go. All right, so that's how we got the GCF of 3x. All right, let's look at B. Is, what is it, 14x to the third y plus 7x squared y minus 7xy. All right, and then here I'm going to write down C and D. So C is 6 times quantity x plus 2 minus y times x plus 2. And D is xy times y plus 1 minus y plus 1. All right. So here the GCF between 7 and 14, that's going to be 7. I'm hoping that's really jumping out at everybody. Between x squared, and x to the third, it's going to be x. Between y, and y, that's going to be y. And then a big old empty set of parentheses. And now divide that by 7xy. Divide that by 7xy, divide that by 7xy, and reduce it term by term. So the y's cancel, x squared, 7 into 14 twice, 2x squared. Y's cancel, one of the x's cancels. 7, remember that's a 1. 7 divided by 7 is 1, so plus x, 1x if you'd like. And then minus, notice I mirror the signs, x, y. 7 divided by 7 is 1. Be very careful. Write yourself a special note on that. That's a really big common mistake that, and I know why it happens. It's because your brain sees a minus sign here in 7xy, and then it sees a positive 7xy, and then it thinks 0. You're not adding though, you're dividing. And so, careful on that. That's a very, very common mistake. All right, so C and D, weird. Look, the LCD happens to be a binomial. What does this have in common that has in common? Well, it would be x plus 2. And so we're gonna factor out an x plus 2. Even if you did it like with the work, the 6x plus 2 would be 2 times 3 times x plus 2. And the y x plus 2 would just be y times x plus 2. And so what they have in common is this entire binomial. That is the LCD. So now we're going to mimic what we did here, how we just wrote the 3x, how we just wrote the 7xy. We're going to write an x plus 2 and then an empty set of parentheses. And then to figure out what did we do? We divided by 7xy, 3x, 3x. We're going to divide both of these terms by x plus 2. And then it cancels away, and that's 6, and it cancels away, and that's y, and then the minus comes down. All right? So, oopsie, there goes my book. It's a little harder when you think about how abstract it is that you have a greatest common factor that's a binomial. That's kind of weird, all right? But the reducing process is a lot easier. This was a lot more complicated of a reducing process to get the 2x squared. Where this, we just boop, boop, wiped out the x plus 2s, and it's just the number in front and the other number in the front. All right? How about this one? This one, LCD, is going to be y plus 1. And then we're going to factor out a y plus 1. And then an empty set of parentheses. And then remember, write it underneath each term. And so y plus 1's cancel. We get xy. And then minus. And again, be careful, because just like what happened here, where everything canceled and it was 1, everything cancels, it's 1. So that's a 1. Or you could think as there's a 1 there in front of it. When there's nothing there, there's a 1 there. So, yeah, it's a little tricky. Okay, so let's look at the next one. Write up those 3, actually. I'm going to write up 3 problems on the board, and then we'll do them. Finish off this page for 6.1. And so this one is, they just want me to find the LCD out of all of these terms. All right. And then on the next 2, we're going to do factor by grouping. And that's just finding the LCD once, twice, 3 times. And I'll show you what that looks like. Once, twice, 3 times. Okay. So here it goes. So what can we factor out of all of these? So look, I have 90, I have 15, I have 18, I have 3. And then now a lot of students, you know, in the past have said, oh, this is going to be really tough because I got to break 90 down into all those little pieces. Yeah, not really. Think about it. You're always limited by the smallest number. So 3. It's 3 or 1. And so 3 goes into that, 3 goes into that, 3 goes into that. It's 3. The number is 3. And then as for the variables, they don't all have, this one doesn't have any variables. So it's none. You can't pull out a variable. So we just do divide by 3, divide by 3, divide by 3, divide by 3. All right. And there we go. 30 plus 5y squared minus 6x minus x y squared. And that one does have more steps, but we're going to hold off on those right now because that one, it looks like we could do factor by grouping, where I would pull out the 5, would that work? And then I'd have 6 plus y squared, and I would pull out a negative x and have 6 plus y squared. Yeah, this can actually be factored down. We'll come back to this part of it. Let's do these 2, and then we'll come back to that part, all right? I was wondering why I left that much space on the... Okay, so here, let's do this. So greatest common factor, once, twice, 3 times. So this is what I'm talking about. Look. What can we just work on just the first 2? What can you factor out of just the first 2? 15x to the third minus 10x, we could factor out a 5x. The GCF there is 5x. We write it down, we do an empty set of parentheses, put a 5x there, a 5x there. Reduce it term by term, so 3x squared minus 2 plus. What can we factor out of the second 2? So that plus is still right there. That's the same plus. All right. What can we factor out of the second 2? Well, I could factor out a 2. And so empty set of parentheses. Whatever you write down over front, you put it underneath. 3x minus 2. Now look, I have a 3x. Oh, wait. That has to be a squared, though. Did I not write down a squared? I forgot a squared right here. Ooh, make sure you write down the right number right away. Okay, there we go. So I forgot the squared on the 10x. So I actually factored out a 5x squared. And so that was a squared and squared, and then that became just 3x. All right. Okay. So now, look, we have a 3x minus 2 and a 3x minus 2. So that's the greatest common factor again. So we write that down one time and an empty set of parentheses. You divide that by 3x minus 2. That's one term. Divide that by 3x minus 2. That's another term. And the hard part is the fact that you factored a binomial out of both of those. But the easy part is the canceling. It's much easier to reduce this than it was to reduce those. So 5x squared plus 2. And we're done. All right, let's do this one. What can I factor out of the first two? I can factor an a out of there. So I divide that by a, I divide that by a. So now look, 2a squared over a, one of those a's cancels. I get just 2a plus, and one of the a's cancel, I get just 5b. Plus comes down. Those are relatively prime. There isn't anything that will come out of it, but that means when nothing will come out of it, the GCF is 1. Divide that by 1, divide that by 1, and then you get 2a plus 5b again. So now check it out. You got a 2a plus 5b, you got a 2a plus 5b. You factored that out. 2a plus 5b times something. And what's that something that's left? Well, that is, let's see, divide by 2a plus 5b. Divide by 2a plus 5b. So just like what we did when we factored out the 5x squared, when we factored out the 2, here, that was a real easy one to factor. You factored out the 2, put the 2 there, put it underneath each term, reduce it, 3x and 2. Same thing is going on here, except I factored out a 2a plus 5b, and I wrote it underneath, and now they're going to cancel off, and I have a plus 1. All right, so now that we've done a couple of those, let's go revisit this one. So that 3 is still in a holding pattern. Look, I can factor a 5 out of the first 2. And then I'm left with 6 plus y squared. Out of the second 2, I'm going to have to factor out a negative x. And so the opposite of x, I factored out a negative x. Why did I do that? Well, because I needed a negative 6x divided by negative x is positive 6. So it looks just like this one. A negative xy squared is the x's cancel, but then I get a positive y squared. And now see what I have. I have 6 plus y squared, I have 6 plus y squared, and so I can factor that out. In the little empty set, and 5 plus negative x, or just minus x. So if you didn't quite follow that one, here I didn't show my work here. 6 plus y squared, divided it out. 6 plus y squared, divided it out. That's where the negative x came from. That's where the 5 came from. All right. Don't worry about it. We're going to look at ones that are harder like that. But for this first one, we just wanted you to just make sure you can factor out the 3. That's why the really, really tough problem is right there. All right. Okay, so let's look at the rest of the problems on 6.1. So factor by grouping, factor by grouping, factor by grouping. And so here, we'll do these maybe a tiny bit faster so you're not sitting in front of this video forever. Right. X cubed plus 4, x plus x squared plus 4. And so look, out of the first 2, we can factor out an x. Whatever I factor out, I put underneath each one and reduce it. X squared plus 4. Those are relatively prime, so the automatic is GCF is 1. Divided by 1, divided by 1, x squared plus 4. They both have an x squared plus 4. There's two terms here. They're separated by a plus or a minus. So this is one term. This is another term. I can factor out the x squared plus 4. Divide that out at each term. They cancel. I get x. Cancel. I get 1. Plus comes down. All right. Now I've had students say, do I have to show that work when I get to here? Can I just write x plus 1 times x squared plus 4? Yeah, sure. I'm going to show all my work every time because these are for your notes. But you can definitely do some shortcuts after you get the hang of it. So out of the first two, I'm going to factor out an x squared. 2x minus 1. Out of the second two, I'm going to factor out a negative 5. Now, why a negative 5? Well, because if I grabbed a positive 5 out, I would end up with negative 2x plus 1, and then it wouldn't be the same as this. I always need these binomials to match when I'm factoring by grouping. So a negative divided by a negative is a positive. A positive divided by a negative is a negative. And now the signs match. Had I pulled just a regular 5 out, I would have ended up with this. I would have had that. And if I had that, you'd be like, okay, I can't finish it. Because this is 2x minus 1, and that's negative 2x plus 1. That's if I would have pulled out a positive 5. I didn't. I pulled out a negative 5, which made that be positive and made that be a negative. And now those are exactly the same. So we can factor out the 2x minus 1, empty set, and then it's going to be x squared minus 5, right? That's going to be what's left inside. And here's the work for it, 2x minus 1. That's what I factored out. Okay. Okay, let's look at 5, and 6, and 7. Okay. And 6, we're gonna have to, rearrange it, huh? 2 plus 18 minus xy. Factor by grouping and rearrange it. Okay, so this one, we could just factor what? 3 out of 9 and 21, a 3. And then x squared y, 3. X squared y is the GCF. 3x squared y, 3x squared y, empty set of parentheses. What goes inside those parentheses is whatever it reduces. So 7x y minus 3. Those all die. All right. Out of the second two, I can factor out 2. And that leaves us a 7xy minus 3 again. So now I got a 7x minus 3, a 7xy minus 3. I factor that out. Write an empty set. Whatever I write out front, I put it underneath each one. And reduce. And the reduced version, that's where the 2 comes from. That's where the plus comes from. That's where the 3x squared y comes from. All right. This one, I can't factor anything out of the first two. They're prime. I can't factor anything out of the second two. They're prime. But if you look at it carefully, I could switch up a couple of these. I could, let's take this guy and move it up to the front here. So we have 2x minus xy. I want the y's to kind of match up. So I'm going to leave the 18 where it is. And then minus 9y. So I rearranged. This one went to the second position. That one went to the last position. Okay, but I didn't change anything. I didn't factor anything. I just rearranged it so it's a little neater. Because now watch. What can I factor out of the first two now? An x, right? So we get 2 minus y. What can I factor out of the second two? Well, a 9 and you get 2 minus y. And now you got 2 minus y and 2 minus y, so let's factor that out. 2 minus y. And what's left after you cancel the 2 minus y? X minus y, 9, and a plus in between it, all right? Awesome. And then one last one, number 7. I'll put that one up over here. Three xy plus 2 minus 3x minus 2y. Okay, so again, let's rearrange. So we'll just switch those two around, I think. 3xy minus 3x plus, I don't know if I want the 2 first. See, I'm worried about the y. I want the y's to match. So let's write the minus 2y and then plus 2. So again, we switched this to the second position and that to the last position. So then it goes y number, y number. That's why I switched it like that, all right? Okay, so I can pull, factor out a 3x. And you get y minus 1. Factor out, oh, that's tough, right? Because I need the y to be positive, but right now it's negative. So I'm going to factor out a negative 2, the opposite of the greatest common factor. And I did that so that this would be positive y and minus 1. And now I got the y minus 1. Empty set of parentheses. Put it underneath each term. Cancel. And write the leftovers. Again, if you wanted to write 3x plus negative 2, so it looks just like that, you can. I just did minus 2. We're lazy mathematicians, all right? So that is called factor by grouping. Next, we'll do 6.2.